go. Okay. I'm going to share my screen with you so that you can see my calculator. I'm going to do my whole screen today, my entire screen. Yes. All right. I'm asking a lot of my computer, I guess. This one, sure. Okay, do you see a calculator? No. Okay. I'll keep trying. Oh. Here it comes. Do you see it now? Yeah, all right. Okay, everybody. Let's talk about matrices. Previously, we were using over here on the side second matrix to store a matrix. A couple of matrices, actually a few, right? We had the ones that they asked us to do in the what was that thing? It was a lab? Whatever it was. And now we're looking at doing other things with matrices here that will help us do groups of math faster. So let's talk about a couple things. Maybe I can put picture in picture here. I don't know. Let's see. Last time we met, we said that a matrix is just an array of objects or of numbers. Now, obviously, it's probably going to be numbers or letters in our stuff. And we're going to talk about the different rules that we get to play by today for adding, subtracting, multiplying. And then we'll use matrices to solve some puzzles, to solve some problems. And I already said that matrices have been used for a long time in coding and stuff like that. You write in some letters, and then you multiply it by another code key, and then you can interpret what the magic code is. First thing we would do, as we saw when we were editing these things, is that we have to determine the size of the matrix. I'm going to go ahead and choose number 3 because it's blank, and right away it's asking us for dimensions. And this one right now, it's set to 1. And these dimensions are always given in rows first and then columns. In rows and then columns. Never do they ever go in the other direction. It's kind of like order of operations. We always do things when we define a matrix, we're saying how big it is by rows and columns. So maybe we'll do a 3 by 3. And it gives me enough space in the little grid for 3 rows, 3 columns. And if you recall down here in the address of the thing, put my cursor right there, that there. The first number is the row, and then the second number is the column. So if I go over one space, now it says row 1, column 2, and row 1, column 3, or row 2, column 3. That's how we define each element in our matrix grid. Okay, so we can have them whatever size that we want to, but it's going to be a rectangular grid of rows and columns. Okay, if I feel like it, I could go up here and I could redefine how big this thing is. I could say I want one that's 2 by 3. Okay, well, 2 rows, 3 columns. And same thing, if we go down here, it'll tell us the address of each of those 6 elements in our grid. And times tables was basically a matrix where you've got your numbers on the side, and then you're multiplying them and putting the answers in the middle. Matrix is singular, matrices is plural, and the symbol for those on our calculators and generally in math is going to be big brackets. So you can see that even up here they've got brackets that are surrounding basically their spreadsheet kind of setup. Now if I'm not doing it over in this part of my calculator, if I back out and go back to the home screen and clear it, you can make a matrix however you want to. Down, where are those brackets? I gotta look at my calculator rather than that one. You see them? Where are the brackets? Oh, they're over by above the multiplication and subtraction signs. If you really wanted to do it the clunky way, which you used to have to do, you could make one this way, but you'd have to use the space bar. You'd have to, where's the space bar? It's down here. You'd have to do stuff like, oh snap, never mind. I don't want to do it the clunky way. I could have a 1x1 matrix. Here we go. Using brackets. It's clunky, but it works. Oh, look at that. It's like, no, you did that wrong. Like, oh, okay, sorry. All right. Obviously, we want to pick whatever size of matrix so if we're going to play around with it on the home screen, we're going to use our alpha key. We're going to go alpha, zoom for the F3, and we get our rows and column thing that pops up. And I'm going to ask it to give me a 2x2. So you scroll up. Oops, too far. Pick a 2x2. And then once the dimension is highlighted, I can say OK. And I'll bring up enough space for me to do a 2x2 matrix. And note the brackets. So it's always their indication. It's always the indication that we're working with a matrix if it has brackets. And it looks a little bit different than absolute value signs. But there you go. And we can just go ahead and type them in from here. Keep using your right arrow to scroll from this one to the lower left. 1, 2, 3, 4. There's our 2x2, and we could go in there and say, well, 1 is in position 1, 1, and the 2 is in position 1, 2, 3 is in position 2, 1, and 4 is in position 2, 2. Okay, again, each of the numbers in there is called an element, and each element has its own little address that's defined by which row and column it happens to be a part of. Rows and columns. All right. Now, you keep your calculator handy, and I'm going to go ahead and go back to my regular camera, and just make sure you pin this camera here. Oh, hang on. Down here to your big screen. I got to do that too so it's on my screen. And I'm going to put some notes here for you. I wanted to stop presenting. Okay. Michaela, I hope you can... Oh, it's backwards for me. Oh, that's no good. Sorry, Michaela. There's not really a whole lot I can do about that. Unpin that for now. Okay. Joy can see it fine, I think. Yeah? It may be a little blurry, but I'll talk you through this. Okay. Hey, maybe I can pin one of my other selves to the thing. Pin over here and say pin this. Pin this! Can I do that? Oh no, that's Joy. I got Joy on my screen now. Say hi to Michaela. Oh. Yeah, everything's reversed. That's not going to be very helpful for you, Michaela. I'm so sorry about this. It's retarded. I'll just put that up again. Okay, Joy. You can see here that whatever numbers we decide to throw into these two matrices, I've got one that I'm going to call ABCD, and I got another matrix I'm going to call EFGH. I got to pin this one. The addition math is very, very straightforward. I think maybe you can even see what's going on in the multiplication, or sorry, in the addition here. It's whatever's in the same position in each matrices that just gets added together in our answer. This is like the answer matrix over here. So we got whatever's in row 1, column 1, plus whatever's in row 1, column 1, gets added together to make our new row 1, column 1 answer matrix. That being said, the matrices, if you're going to add them together, they have to be the exact same size. So I'll put something on the calculator screen here. I got to build another matrix for Michaela. I'm going to put one in here, another 2 by 2, and I'm going to add 1, 2, 3, 4 to 3, 2, 1, 1, just for fun. Okay. So I've got a 1, 2, 3, 4 matrix plus a 3, 2, 1, 1. And again, this is pretty straightforward. If I go 1 plus 3 is 4, 2 plus 2 is 4, 3 plus 1 is 4, and 4 plus 1 is 5. And I get my answer, 4, 4, 4, 5. So matrix addition is like really, really, really easy. You have to try to get those ones wrong. Okay. Subtraction would work the exact same way. I can take the same exact thing, and I will. Let me do this like I'll do it with my pen, and then I'll do it up on the screen. So I got like a 1, 2, 3, 4 matrix, and I'm going to subtract 3, 2, 1, 1 from that. So my answer is going to be what's in the first, what's in the element 1, 1, and I'll do basically up here it'll be 1 minus 3. And then in the upper right would be 2 minus 2. And in the bottom left would be 3 minus 1, and in the bottom right would be 4 minus 1. Okay, on my calculator I'm going to go back up. I'm going to grab my original matrix, but I'm going to switch the sign, Michaela. I'm going to go in there and I'm going to switch that plus to a minus. And now when we hit enter, we see that it basically did the math for us. So 1 minus 3 is negative 2. 2 minus 2 is 0. 3 minus 1 is 2. And 4 minus 1 is 3. So addition and subtractions is very, very easy. The only thing we have to make sure of is that the two matrices have to be the same, or have to have the same dimensions. Okay, now I'm going to talk about some of the other properties the matrices have. They have rules that they have to play by, and they're not exactly the same as the rules for like integers or rational numbers or things like that. The first property that I want to talk about is called identity. It's called identity. So we had that for regular real numbers. We had that a plus 0 equals a, and we had that a times 1 equals a. Those are both identities, the identity property of addition and the identity property for multiplication for real numbers. We have something very similar to that for matrices. We have to have a do-nothing matrix, and you already have it stored in your calculator if you did it the other day. If you go to second matrix, we stored it as number 9. We stored it as a 2 by 2 identity matrix that was 1, 0, 0, 1. This is kind of like, well, it's got 1s and 0s in it, right? That's what identities have in it. They have 1s and 0s. And we could also define it as like this term's turned on, this one's turned off. 1s and 0s could mean on and off. And when we multiply any matrix by that matrix right there, we get nothing that changes. So maybe I'll take my 1, 2, 3, 4 matrix, and if I multiplied it on my calculator. So I'm going to take the identity matrix. I'm going to multiply it by a 2 by 2 matrix of 1, 2, 3, 4. Just to prove it to myself that my calculator knows how to do a matrix and get an answer of 1, 2, 3, 4. It knows that it does nothing. So for multiplication, 1, 0, 0, 1 is our multiplicative. That's a hard word to say. Multiplicative. The multiplying identity for a matrix. And you can multiply that identity matrix on either side. In its case, it doesn't matter which one comes first. For every other matrix, order matters. Additive. About additive. What would I add to a matrix to make it do nothing? I'll take the matrix 1, 2, 3, 4. What matrix do I have to add to that matrix to not go anywhere? I hope the answer is somewhat evident. Okay, I'm going to go and I'm going to take, on the calculator, I'm going to bring up my first matrix, matrix A, whatever that was. It was negative 2, 0, 7, and 3. And I'm going to add to that the dummy matrix, the do-nothing matrix, for addition. And actually, when I ask for a 2 by 2, it pops up on my screen. It's just 0, 0, 0, 0. Right? 1 plus 0 is 1, 2 plus 0 is 2, 3 plus 0 is 3, 4 plus 0 is 4. Or whatever matrix that you have, and you add it to the matrix 0, 0, 0, 0, the 0 matrix, and you get exactly the same thing that you started with. You went nowhere. So we need that in our back pocket too. That is the identity matrix for addition. 0, 0, 0, 0. I don't know, there's no point in storing that anywhere. We just kind of have to conceptually have it in our back pocket. All right. Now, we're going to use the two matrices that we had stored from the other day. We're going to use matrix A and matrix B. Just as a reminder, matrix A was negative 2, 0, 7, and 3, which you can see on my calculator screen, Michaela. And matrix B, let's see what that one was equal to. That one was equal to 1, negative 5, negative 3, and 0. Okay, so I'm going to show you a property of matrices that's a little bit different than we had with our normal numbers. And that would be that matrices are associative. Let's say that we even had a third one in there, and I don't even know what I would call it. I mean, it'd be C, and I'll just C will be my 1, 2, 3, 4 matrix. Maybe it could even go in and add a C matrix in there, call it 1, 2, 3, 4. So I'm going to go do that. I'm going to matrix. I'm going to go over to edit, and I'm going to go into number 3, and I'm going to change this to a 2 by 2. And then I'm going to define it as 1, 2, 3, 4. 1, 2, 3, 4. And that'll be matrix C. Oh, come on, thing. 1, enter. 2, enter. 3, enter. And 4, enter. Okay, so I got an ABC now, exactly what Joy can see on the screen, and what we've got here under matrix, second matrix. And what I'm going to do here is I'm going to go back to my home screen. I'm going to show you that this property is true. Matrix A times the product of matrix B and C is equal to if I grouped them differently. Like if I multiplied matrix A and matrix B together first, and then multiplied by matrix C. Okay, so this property here is called the associative property. Associative property of multiplication. And that's true. It doesn't matter how you group them. I could take matrix A times matrix B. I could get an answer for that first. When I multiply my matrix A by my matrix B, I get -2, 10, -2, and -35. If I take that answer then, and I multiply that by the third matrix, by matrix C, I'm going to get a grand total answer. It's a really big mess of 28, 36, -107, and -144. Okay, that's if I grouped A and B together and then took that answer and multiplied that by matrix C. All right, now I'm going to do it in a different order. I'm going to go ahead and get my calculator to multiply B and C. I get to group those two together. And then I'm going to take my matrix A. I'm going to multiply it by that answer. So I get an answer for B times C. And then I'm going to go A times that answer. A times, I guess got to pull it down. Answer. A times the answer. And I get the exact same answer that I had when I grouped things in a different way. I'll get 28, 36, -107, and -144. So that's the same as most number systems. You got the associative property. We can group things and go from left to right. And it's similar to taking something like 1 plus 3 plus 4 and going, well, 1 plus 3 is 4, and then adding 4 to that, that makes 8. Or maybe I should go 1 plus, well, 3 plus 4 is 7. 1 plus 7 is also 8. Okay, we're just going straight from left to right and just grouping things in a different order. And that's good. But one thing that's different about a matrix is that the other main property, commutative property for multiplication, that's not true for matrix multiplication. Now, it's true for addition. It's true for addition. It doesn't matter which order I add matrices in, that's always true. You'll get the same answer. But for multiplication, order matters. Order matters. And that's because it's doing several operations at once. Okay, it's like, does it matter if you use the dryer first and then the washing machine, or if you use the washing machine and then the dryer? Do you get a different result? Yeah. So that would be kind of disastrous, right? Dry your dirty clothes and then wash them. And you pull it out, now you have wet clothes. They're clean, but they're wet. But if you take your dirty clothes, put it in the washing machine, and then dry them, now you can actually wear those clothes. So it's definitely different. That's the way that it is with matrices. They are not commutative when you multiply them. Let me show you this really quickly. Let's say that you take your matrix A and you multiply that by your matrix B. If I do it in that order, I get -2, 10, -2, -35. But if I do it in the opposite order and I put the B matrix first, matrix B times matrix A, I probably will get a different answer. And this time I get -37, -15, 6, and 0. So it doesn't work like 3 times 2 is 2 times 3. It doesn't work like that. There are special matrices that work when you do commutative, but they're related to each other. Okay? For addition, yes, it works, but for multiplication, order matters for a matrix. Order matters. Let's talk about another one here. We're not even really getting to the nuts and bolts of some of these things. We're not going to tell you how the multiplication works yet. We're going to save that for some other day. But I want to talk about inverses. Most matrices have inverses. Okay, then you've got a little symbol up over where you click on the matrix buttons, x to the negative 1. So if you pick a matrix like your matrix A, and then you click the button to the negative 1, I think we did that in the thing a couple days ago. We get a matrix. We get another 2 by 2 matrix. Mine's got like fraction or decimals, so I'm going to change that into fractions because it bothers me. Okay. Every now and then you'll get a matrix that has no inverse. And that would be in this special case. And it's in your book that if the determinant, that little game we played 2 days ago with the matrix, the slanty-wise little multiplying and subtracting, if the determinant of a matrix is equal to 0, then the inverse of that matrix does not exist. So let me write one for you that does not have an inverse. Matrix A did, but how about all 2's? All 2's. You can see what's going to happen when you multiply 2 by 2. It's 2 times 2 minus 2 times 2. Okay, so here I guess I'll make a 2 by 2 matrix that's all 2's. And you can try it on your calculator. All 2's. Okay, that's a good matrix. We can add it to another matrix. But if we ask it for an inverse and do the to the negative 1 power thing on it, I get this error message. And it says, no, that's a singular matrix. No inverse matrix exists. Calculated result not found if dependent on a matrix inverse. It's like you just broke it right there. I'm like, oh man, I am so sorry. So because the determinant multiplies slanty-wise from the top left to the bottom right, and then subtracts the product of from the bottom left to the top right, 2 times 2 minus 2 times 2, this one has no inverse. It will not work. Its determinant was 0. So that's a clue. That's a special little property of matrices that I think is kind of cool. Fact. All right, we've got till 11:30 today, okay? So we've got about 13 minutes left. Okay, we already talked about subtraction. Subtraction is no problem. That's the same as addition. One element at a time. No worries there. Let me get rid of this stuff on my calculator. And if you would look now at example 3 in your book, this will, this will be like we're trying to find the missing matrix. Okay, so it's got a matrix 3, 7, 9, and 1. And then it says we're going to add to that some mystery matrix X. And when we add that, we get 5, 9, 2, and negative 6. Okay. Now, this big X represents a 2 by 2 matrix. Okay. It represents a 2 by 2 matrix. We have to figure out what it is. But we know that 3 plus something equals 5. Okay? So we just do a little bit of mental math. 3 plus something is 5. That answer must be 2. 7 plus something equals 9. Well, that answer must be 2 as well. 9 plus something equals 2. Oh, wait. That would have to be a negative, right? 9 plus a negative 7. And then the last one in the bottom right corner, 1 plus something is negative 6. Well, that's going to have to be a subtraction problem as well. 1 minus 7 is negative 6. So we'd have a 2, 2, negative 7 matrix for our answer. if we did 3 plus 2 is 5, we can figure it out. So it's kind of like working backwards. Another way you could do this would be to solve for x by subtracting the first matrix, the 3, 7, 9, 1 matrix from both sides. That's totally illegal. What you would get would be that x equals the matrix 5, 9, 2, negative 6. Now I got to do it the other order. I got to put that other one. No, that's okay. All right. 5 minus 3 is 2. Minus 2. Yeah, I can do it. 5 and 9 and 2 and negative 6 minus 3 and 7 and 9 and 1. That's the exact same problem right there. So if that helps, then you're going 5 minus 3, 9 minus 7, 2 minus 9, and negative 6 minus 1 to get the answer matrix that they have there in the book. Okay, the last bit, I guess I have two last bits here. Sorry. Matrices have a lot of like rules that they have to follow, but they're pretty straightforward when you start doing some of the math. This is maths. Okay. Example 4 says solve for A, B, C, and D, and they write it out as like a little problem. They say we got this weird matrix where the first element, element 1, 1, is A plus 12. And then our 1, 2 element is 2B. And our 2, 2 element is D. And they're saying that that matrix is equal to this other matrix, 18 and negative 14, and the sum A plus C and 3. Now, if they're equal to each other, that means that A plus 12 is equal to 18 because they're both in the upper left corner. Okay, that's just a basic algebra problem. You can solve for A using that information. A plus 12 is 18. A must equal 6. Upper right corner of both of them. This says that 2B equals negative 14. Okay, well that's pretty easy too. Divide both sides by 2. B must equal negative 7. All right, so we got A in our pocket. And they even got a really easy one here. They say that D equals 3. All right, that's just given to us. And the last one is in the bottom left where they say that 23 equals A plus C. So we have to have solved A first. The A was 6. We replace A with a 6. And now 23 equals 6 plus C. We'll do a little bit of math there. We can solve 23 minus 6 is 17. C must be 17. So they'll set it up with equality there. And we're just matching up the element in the top left of this side with the element in the top left of that side. They must be equal to each other. And so we've got enough information to solve like a mini puzzle problem there. Last element, last rule for matrices. And that would be scalar multipliers. This is kind of weird. You're allowed to multiply a matrix by a matrix, and you're allowed to multiply a matrix by a whole number. Well, let's do 2 times our 1, 2, 3, 4 matrix. Okay, so Michaela, that's going to be 2 times, and I'll make a 1, 2, 3, 4 matrix here. 1, 2, 3, 4. So I didn't even tell you what you're doing when you multiplied a matrix by a matrix, but this is much easier. What happens when you multiply 2 by 1, 2, 3, 4? Well, it doubles every element in the matrix. So that equals now 2, 4, 6, 8. So that's a scalar multiplier. It multiplies everything in every space of that matrix by 2. It doubles it. We can also, and there's no such thing as division in with matrices. I know it kind of seems weird, like, well, you can multiply, but you can't divide. Well, you can kind of get around that. If I would like to shrink it in half, I'm going to multiply by 1/2. I'm not going to divide by 2. I'm going to multiply by 1/2. So I could take my 1, 2, 3, 4, and I can say, well, let's do a fraction. 1/2 times, and I'll do the 1, 2, 3, 4 matrix again. Okay, it's kind of like tricking the matrix into doing division, but again, it's just shrinking it by a factor of 1/2. Okay, it's the exact same thing as dividing here, but our calculators won't let us. I don't think they'll let us do division. Okay, so I get 1/2, 1, 3/2, and 2. I'm going to give it a try though. I'm gonna go in here and I'm gonna try to pull up a matrix divided by something and see what it does. I mean, technically speaking, it probably shouldn't work, but maybe the calculator won't know any better and it'll just treat it like multiplication. So I'll see what happens here. And it says, wrong data type. Sweet. Our calculator will not divide a matrix. So you're going to have to multiply a matrix by a scalar multiplier to get it to reduce all of the elements in half, or whatever you want to do. You can even multiply by a negative number, and that's fine as well. 4 divided by 2. Yeah. Okay, those are some of the rules for matrices. I know there's like a lot of rules right off at the start, but the adding and subtracting are pretty straightforward. The multiplying, you're just going to let the calculator do some of that kind of stuff. And the rest of it is based off properties of equality and then scaling things up and down. I like matrices because the calculator can do a lot of the math for you. It's just kind of getting used to them and knowing what you're actually doing when you're pushing the buttons. I like you to do reteaching 5, which we verified that you all have. And then from the lesson, numbers 6 and 7, 14 to 16, 18 to 21, and 23. And that'll be due on Friday. So again, if you run into problems, like if you start that reteaching and you're not quite sure what to do, please let me know and we'll crank that one out. That won't be hard at all. I think matrices are super cool. You're going to add, subtract, even like big ones, 3 by 3s. You're just going to add straight across. And on the back side of it, you're going to do some like little equations with matrices, which we did. And yeah, I think it should be pretty straightforward. You just kind of use your fingers. Okay, I always use my pointer fingers for matrices to like this one goes with this one and then this one goes with this one so that I don't lose track. Especially when they're like 3 by 3s, it's really tough to sometimes keep your eye on the same element in each matrix. So just use row, column, row, column, row, column. Make sure that you're adding or subtracting the same element in both matrices, and then you should be fine. You should be fine. And if not, like I said, I have office hours. So use them. It's free, right? Okay, that's all for matrices. We're going to add a little bits of things throughout the year. I think they kind of like hold off on doing anything really new with matrices for a while. So it might even be the second semester until we really kind of develop it a little bit more. But it's used in computer programming and all that kind of stuff all the time. And it's pretty easy to use with our calculators. So enough said. I'll let you go like 1 minute and 12 seconds early. Sweet. We'll see you later. And I'm going to get this loaded for you, Michaela.